Alright guys, so for this little shortcut video that I'm going to try to show you, I picked a more complicated problems because hopefully you have already practiced and you've moved beyond being worried about the square roots of 18 and that kind of stuff. But ones like this might still bug you a bit. So the first thing to point out and notice about this is that there is that square root of 2 coefficient that's already there, and it's really important that you keep an eye on that guy and make sure that he doesn't get lost in the shuffle. But for this, the first thing I want you to see is that when you see this 288, you probably don't have factors that instantly jump into your head, like with 18 and with 100 and the other examples. Those you kind of know what to multiply, but here you don't know right away. So first thing to notice is this ends in 8, which is an even number, so I know that it's divisible by 2. You might want to try some of your other examples of things. We have rules for how to divide by 3 or how to know that something is divisible by 3. Same thing with 6 and 4. If you know those rules, they can be really helpful. If you don't know those rules, I would recommend Googling it or asking your classmates or another teacher because they are helpful to know and it might be worth writing down. But for this, I'm just going to go ahead and divide by 2. I've got a calculator down here, and that's another thing, is you can always just go through, and if you're not sure, just start dividing by stuff. Like the rule for knowing if something's divisible by 7 is really complicated. It's much easier just to test it out. Divide by 7 and see what happens. Oh, look, I got a decimal. Clearly that's not divisible by 7. So you can always kind of just guess and check that way. But 288 divided by 2 gives me a nice pretty 144. So as with the previous example, I'm going to start by separating. I'm first of all going to not use that pen. Let me get my normal pen back. Sorry about that. I'm going to start by separating my coefficient here and these variables because it's just a good practice to kind of have those separated because then you're less likely to forget about your variables in the process. So 288 divided by 2, my calculator just told me that it's 144. Now, here's the shortcut part of it. 144, we could continue to divide by 2. We could see that that's going to be divisible by 4 since the last 2 digits are divisible by 4. We could do that. 4 plus 4 is 8 plus 1 is 9. It's divisible by 3. The fact that it's divisible by both 2 and 3 means it's divisible by 6. But the other thing that I know about 144 is that it's 12 times 12. Now, I told you in the first video that you needed to do prime factorization, which means you need to keep going until you can't go any farther. But I'm going to tell you now that you can break that rule if you have a good reason. And right here, I have a really good reason to break that rule. 12 times 12, there's my perfect square. I don't have to go any farther because I can take care of the fact that I'm looking for a perfect square right here at this step. By the same token, up here, my m's, I can go ahead right now and say, I don't need to write out m times m times m 10 times and then pair them all up. I know that I'm going to have 5 pairs. I'm going to have an m to the 5th times an m to the 5th. Because remember, that exponent rule that you thought we were learning for no reason comes into play right here. M to the 5th times m to the 5th, I would add 5 plus 5 and get m to the 10th, which is this. So there's another perfect pair. I'm going to switch to a different color here and say M5 and M5 is another pair. So when I rearrange my radical now, remember that I still have this 2 out here in front. So I've got 2 times, I've got my 12 times 12. I've got my m to the 5th times m to the 5th. And then I've still got that little 2 that was a prime number that didn't have a pair. So then square root of 12 times 12, or the square root of 144, is 12. So I've got that coefficient of 2 being multiplied by 12. Square root of m to the 10th is m to the 5th, as evidenced by the fact that I have two pairs of m to the 5th. And then I've still got that root 2. So when I put all this together, 2 times 12 is 24, m to the 5th times the root of 2. Guys, this identifying perfect squares that aren't necessarily primes can save you so much time, because think about the fact that I would have had to keep going and do 6 times 2 on both of these, and then my 6's would have to be 2 times 3 and 2 times 3, and then I'd have so many more of my little pairs of radicals as I go along. Same thing with my m's. If you can notice that your variable has an even number here, then go ahead and just split it up into two equal sets. Even if you had something like the square root of m to the 15th, I'm going to split that into m to the 14th times m to the 1st, or just m, because my m to the 14th can be looked at as 7, m to the 7th times m to the 7th. And then I can just really quickly go m to the 7th times the root of m. Finding that even number of exponents here, or finding those buried perfect squares, make life so much easier. So hopefully this was a little aha moment, or maybe you already realized that and have already been doing that shortcut, but I just wanted to take a minute and show you. So let us know if you have any questions. If this confused you more, then just go back to doing your prime factorization. That's fine too. See you in class.